Hello, and welcome to this Synergex Professional Services Group webucation session entitled UI Toolkit Composite Windows. My name is Steve Ives, and I work in the Professional Services Group at Synergex in Gold River, California. This presentation is geared towards UI Toolkit programmers who wish to learn about UI Toolkit support for Composite Windows, which was a new feature added in Synergy version 9. From Synergy version 9, the UI Toolkit now has the ability to create and process composite windows. A composite window is a single container window which can contain other child windows. When processed at runtime, the composite window appears to the user and behaves like a single window. Conceptually, and in fact practically also, composite windows are very similar to the existing support for processing tab set windows. The differences are that whereas a tab set window allows you to process multiple child windows in a container, but only see one of those child windows at each time, composite windows allow you to see all the child windows at the same time. The tabbing sequence within a composite window includes the various child windows. So as you tab off the end of an input window, for example, focus will seamlessly move to the beginning of the next child window. As with tab set processing, each child window is associated with a processing method, and that processing method is called whenever the child receives focus within the composite window. Unlike tab set processing, however, UI Toolkit provides default implementations for these methods, which can enable you to receive basic functionality with much less code. The process for using composite windows is relatively straightforward. First, you create a composite container window, and then you add the various child windows to the container. Provide any custom processing methods that are required in order to process the children in an appropriate way, and finally, you process the composite window in an event loop, just like you would with other toolkit window types. On this slide, you can see an example of how a UI Toolkit application might be implemented without support for composite windows. At the top left, you can see a list window. The list contains information about customer records. At the top right is a second list window. This list is displayed when the user double-clicks on a record in the customer list and contains all of the contacts for the selected customer. When the user double-clicks on a contact record, the tab set that you can see on the bottom left is displayed. The tab has various pages, allowing the user to view and maintain all of the information about the contact. In this screenshot, you can see that the contact's call frequency graph is being displayed. Finally, in the bottom right, you can see an ActiveX control container. This window is displayed when the user clicks on the photo button in the Contact Details tab set. If I were a user of this application and I wanted to switch to a different contact for a different customer, I'd need to close the photo window, close the contact details window, close the contacts list, select another customer account, and finally select the new contact. Here we can see a list of the types of windows which can become children to a composite container window. As you can see, the Composite Window API supports adding input windows, lists, and tab sets as children. We also support adding the older selection and text windows, as well as ActiveX container windows. The API even supports embedding one composite container as a child inside another composite container window. As with tab set processing, each child in a composite container is processed by a specific named method, which you specify at the point where you add the child to the container. In the case of composite windows, however, UI Toolkit provides a default implementation of these methods for each supported type of child window. These methods only provide fairly basic functionality, but in some cases they will be functional enough so that you don't have to write each method yourself. We'll discuss what each of the default processing methods does shortly, and the functionality of these default methods is documented in the UI Toolkit manual. Of course, if the functionality provided by the default methods doesn't meet your requirements for a given child window, then you can simply write your own processing method for that child, just as you would do with tab set processing. The approach is basically the same. Write the method adhering to the documented API and register the method for use by naming it when adding a child to the container window. Again, similar to the tab set API, the Composite Container API is actually very simple. In fact, there are only two routines involved. The ccontainer routine is used to perform overall manipulation of the container window. Create a container, add a child, set focus to a child, and so on. Once a container has been created and configured, it's then processed with the C process routine, which works in a very similar way to the TS process routine. Really, all the CS process routine does is manage the overall container. It simply ensures that focus is set to the appropriate child at any given point in time, and then calls the processing method for that child. All of the real work takes place in the child processing methods. Here's an overview of the functionality of the C container routine. As you can see, the first parameter to the routine is a .define, which tells the routine what you're trying to do. And then there are additional parameters depending on which subfunction you're actually using at any point in time. The main subfunctions are DC create, which creates a new composite window, DC add, which adds a child to the container, and DC context, which sets or gets the context for the currently active child. As you can see, there are also several other subfunctions, many of which expose various information about the container and its child windows, and some of which allow you to perform customizations to the container. Here's how we create a new container. As you can see, we provide a name for the container, or if we pass a blank name, UI Toolkit will generate a unique name for us, and we specify the height and width of the window in rows and columns. We can also optionally specify a title for the container window itself. By default, container windows are not placed when they're created. So after creating a container, we can manage the container like we would any other window. We can use uWindow to place, remove, and delete containers, and uWindEvents to assign window event method sets to a container, uIcon to set an icon for the container, and so on. As you can see, ccontainer DC create returns a container window ID. We can create and process multiple containers simultaneously by maintaining a separate ID variable for each of the containers. Once we have a container, we can start to add child windows to the container. All child windows fall into one of two categories. List windows are added using the DC list function, and all other child windows are added using DC window. Notice that you specify the child to be added by specifying its ID. So you first need to load input windows or ActiveX controls and create lists or tab sets before adding them to a container. When you add a window or a list to a container, any borders and title will be disabled. If you wish, you can re-enable them, but on Windows at least, the resulting UI might look a little strange. If you pass a window position when adding a child to a container, then the child will be placed on the container at that position. Otherwise, the parent-child relationship will be established, but the child will not initially be placed on the container and hence won't be visible, until you make it visible by placing it later on. Adding a child to a container will cause a specific window events method set to be applied to the child. This method set traps left-click events within the child, so that focus or change due to the user clicking around between children can be processed. Any method sets which were already registered to the window are then registered as extensions, so that other events will continue to be detected and dispatched as appropriate. If you add a child to a container and that child is too large to be displayed in the container, then scroll bars will be added to the child. When you're working with composite containers, any one window can only be a child to a single container window. You'll notice that one of the arguments to DC add is a record index. This parameter allows you to specify which of the method data arguments will be passed to the processing routine for that child as the main record or data argument. You'll see how this is used a little later in the presentation. The method argument is where you would specify the name of a custom processing method for the child being added. If you don't specify a method name, then Toolkit will examine the type of child being added and use the default processing method for that type of child. If you wish, you can use the tab index argument to explicitly specify the tab sequence of the child window within the container. If you don't, then the tab sequence between the child windows will default to the order in which the children were added to the container window. The relative placement of the children on the container window is not used to determine tabbing sequence. You'll also notice that you can specify the ID of a menu column when adding a child to a container. If you do, then cProcess will ensure that the associated menu column is placed on the menu bar of the application whenever the child is being processed. Of course, you can add buttons to composite windows in the same way that you would with other window types, using the BButton and BButton set routines. The usual rules apply. Buttons can be placed at the beginning, center, or end of the bottom or right margins of the container. If any of the child windows have buttons, then those buttons will be displayed within the container as you would expect. UI Toolkit now has added support for input windows which only have buttons, no fields. While this sounds a little strange, by adding such a window as a child in a composite container, it's now possible to place standalone buttons at almost any position within the container window. As we've already mentioned, the tabbing sequence between the various child windows within a composite container is determined either by the order in which those children were added to the container or according to the index values that you specified when adding the children to the container. Of course, the tabbing sequence within a child is determined in the normal way for that child, by the order of the fields in an input window's set, for example. You'll need to be aware that Toolkit list windows don't have the concept of a tabbing sequence, so buttons on a child list are not included in the overall tabbing sequence when within a composite window. In other words, tabbing off a list will shift focus to the next child in the composite container, not to any buttons that the list may have. Notice the red star on the current item in the customer list, which will show you where focus will move as the user tabs through this particular composite window. So as we tab from the customer list, the focus is going to shift not to the buttons on the list but to the contacts list, and we shift from the contacts list down into the next child, and because we tab to it we go to the first field on that child, in this case a tab set field. As we carry on tabbing, we'll move context through the various fields in the input window and then off to the buttons that are associated with the tab set, and finally to the close button, which is actually a button which is associated with the container window itself. If we carry on tabbing, we'll cycle back around to the customer list again. Of course, if the user uses Shift Tab, then the tabbing sequence will be the reverse of what you've just seen. But this is something that you must code for if you're not using the custom child processing methods. There are new routines in the toolkit which will help you do this, and we'll see these a little later. Once you've created your composite container and added your child windows to the container, you can process that container with the new cProcess routine. cProcess is a very simple routine because, as discussed earlier, all it really does is focus one of the child windows and execute the processing method for that child. You'll notice that you pass to cProcess the ID of the composite container to be processed and any method data, up to the usual 20 arguments that you would like to be passed on to each of the processing methods as they're called. Remember that when you added each child to the container, you have the opportunity to specify a method data index. This is the number of the method data argument to be passed to that child's processing method as the main record or data argument. cProcess does trap and process several reserved menu entries, which allow context switches to other children within the container. These menu entries all begin with C underscore, and as mentioned earlier, it's a requirement that if any child processing method encounters any C underscore menu entry, it should return back into the cProcess routine to allow the appropriate context switch to take place. This slide shows the various reserved menu entries that are supported by cProcess. C first and C last will cause the first or last child, or button in case of C last, on the container to receive focus, while C prev and C next will focus the previous or next child or button. C reset takes into account any programmatic context change, for example using the DC context subfunction or the DC button focus, and resets the context in a composite window to the currently active child window, list, or button. C set N makes the child window or list with the tabbing index N the active child. This slide shows us an overview of the whole process for creating and processing a composite container window. First, a program creates a composite container and adds one or more child windows to the container. The program then calls cProcess to process the container. cProcess decides which child should be activated, focuses that child, and calls its processing method. Each processing method processes its child in the usual way, with IInput, LSelect, TSProcess, cProcess, or AXProcess, for example. Methods may process whatever menu entries they need, but if a C_menu entry is encountered, which signals a change in context within the container, then the method returns into cProcess. cProcess will then take whatever action is necessary based on the menu entry being signaled, and will call the next processing method as required. You could design a processing method to process more than one of the child windows, but any one processing method should usually only process one type of child. This slide shows the methods which Toolkit uses as default processing routines for the various supported child types in a composite container. As already discussed, the Toolkit manual provides some documentation for these default methods. We also ship the source code for the default methods in the file wind:/ctrmethods.dbl. If you're using Workbench version 9.11b or higher, the default methods are also included as Workbench item templates, providing you with an easy way to create your own custom methods based on the default functionality as a starting point. If you have Workbench 9.11b or later and are not familiar with item templates, then try opening a project and then select Add New Item from Template from the Projects menu. Let's briefly go through the basic functionality provided by the default processing methods for each of the supported child types, and we'll start off with input windows. The default input window processor first uses the new routine iCtrContext. This routine sets focus within an input window based on the reason that focus was shifted to the child in a container. For example, if focus arrives here because the user tabbed to the child, then the first field in the input window is focused. If, however, focus arrived at the child as a result of a shift tab, then the last field or button in the window should be focused. IInput is then called to process the current input set in the input window, and the processing routine's data argument is passed to IInput as its data argument. And all of the method data arguments are also passed on to IInput to support any underlying field methods which may get fired. When input is complete, the method then signals the cNext menu entry to cause focus to move to the next child in the container, and then returns into cProcess. The default list processing routine uses the new LCellStyle routine to turn on the current selection bar in the list. Note this does not affect ActiveX lists where the selected item display is always on. And on VMS and Unix, the method then ensures that the list is enabled. The list is then processed using LSelect with a no-op request. The data argument is passed on to LSelect, as is the method data passed to the routine propagated into the list processor. When an item is selected, the method signals a cNext menu entry, redisables the list again on Unix and VMS, disables the current item selection in the list for non-ActiveX lists, and then returns back into the cProcess routine. The default method essentially allows an item to be selected, and when it is, focus moves to the next child. The default tabset processing routine is very simple. It uses the new TS_tabset DTX_CTR_context function to set focus within the current tab page in the same way that we discussed for input processing. And then it calls TSProcess to process the tab set. Again, the method data is propagated into TSProcess and then on into TSProcess's processing routines for each tab page. For ActiveX child windows, the default processing method retrieves the ID of the underlying ActiveX control from the ActiveX container which was actually added as the child to the composite window, focuses the ActiveX control by setting its ext focus property, and then processes the control using AXInput. Composite window children are processed by setting the context in the child container based on the event in the parent container causing the child to become active, and then processing the container with cProcess. I'm not going to go into too much detail about the default processing methods for the other child types, because they're really going to be rarely used, if ever. Any selection windows are processed using SSelect, text windows using TEdit, and if a general window is processed, focus will simply skip to the next or previous child because a general window only contains text and doesn't have anything which actually can be processed. If you do need to write your own processing methods to override or extend the functionality provided by the default methods, then this is the interface that you must adhere to. And the interface is the same for all types of children. The parameters that are passed to a processing method are the ID of the container, the type and ID of the child to be processed, the reason for the method being called, which essentially tells you whether the routine was called in order to reach the first or last child, the previous or the next child, or because focus was explicitly set on a child by a mouse click or directly from code for example. This information can then be used to ensure that focus is set appropriately within the child that's being processed. Methods can also receive a record or a data parameter. If a method data index was specified as the child was added to the container, then they will receive this record in this parameter, and each will receive any method data arguments that were passed to cProcess. The job of the method is to do whatever it needs to do in order to process the child concerned, and then to xreturn to cProcess if any of the C_menu entries are encountered at any time. If you need to change the context of the container window from within your code, then you basically have two options. You can use the ccontainer dccontext function to explicitly change context to a specific child window, or if you're in or below a child processing method, you could also use msignal to raise one of the C_reserved menu entries. In both cases, the context switch in the container will not occur until you either call or return into the cProcess routine. We already mentioned these three new routines in other areas of the toolkit. Each basically helps to provide improved support when processing windows as part of a composite container window. I won't go into these routines in detail, but I would recommend that you review the documentation for each when you first start working with composite windows. Okay, let's take a look at an example of a program both before and after the addition of composite container windows. The program you're about to see in both cases is actually two separate versions of the same program. So the code in the existing routine was slightly re-engineered to introduce the overall container and restructure the code slightly in order to allow the child windows to be processed as part of that container. Okay, so here we can see the original version of the program. As you can see, when we first run the program, we're presented with a list of customers. The program allows us to scroll around the available customers. We do have the functionality to edit any particular customer record at this point. We can also create new customer records, and we can delete customer records. I'm not going to go ahead and do that because that might spoil the rest of my demonstration. When I pick a customer and drill down or hit the contacts button, I'll double click on this item, I then view the list of contacts for that particular customer. And again, I've got similar functionality in here. I can move around the contact list. I can specify that I want to edit a contact, and that will drill me down into the information for that contact. I can browse around all the information for the contact, and if I wish, I can go off to the final window and view the contact's photograph. Okay, fairly typical application. One of the problems here is that if I want to go and back out of this contact and select another one, then because these are all separate modal forms being processed individually, I can't do that. I've got to close this window, close this window, close this window in order to switch to a different customer and then drill back down into the information for that particular customer. Okay, so let's get out of here. What the hell? Okay, so here we have the version of the program after we've made the modifications and introduced the composite container processing. And I think you'll agree the user interface immediately looks a lot more pleasing. But not only does it look more pleasing, it's a lot more functional as well. I've still got the ability to move around in the customer list, but as you can see, as soon as I move around in the customer list, the contacts for that customer are being loaded and are available to me. The first contact information is being displayed in the contact information tab set at the bottom of the window, and indeed I can see the contact's photograph all in one go. And as I move around within these different windows, I still have the ability to view different contacts without having to drill down and drill up and so on. Equally, I can switch customers and get the same thing. So it's much easier to use. If I want to change something, I can just move down into the details area and make my changes. At any point I can switch contacts, switch customers, and so on. Still have the ability to do the other things as well. So I've still got the old edit customer window appearing above here, and the create and the delete, which will go off and delete all the contacts as well. So fairly straightforward, not too difficult to achieve. In this case, it literally is the same code, re-engineered a little bit to structure the thing into a container window rather than just a collection of individual windows being used. Well, that wraps up our overview of the support for composite containers in version 9.1 of UI Toolkit. We hope that you found this presentation to be useful and informative, and welcome any feedback that you may have through your Synergex account manager.